Okay, so one thing you need to be very familiar with are the graphs of y equals sine x and y equals cosine x, and their various different transformations. And I'll go more into those in a different video, but right now I want to look just at the basic function y equals sine x. So y equals sine x, one thing you need to know about it is that it has a period of 2 pi. What that means is it repeats itself every 2 pi. And the 2 pi is in a unit called radians, and I'll explain those in another video as well. But just think of it as the x-axis right now, and every 2 pi it completely repeats itself. And sine x also has y values between -1 and 1. It's always between -1 and 1 if you have y equals sine x. And then here's how it looks. So you have sine x starts at the origin at 0, 0, and it has period 2 pi. So it's going to go to 2 pi, and it'll have the same thing over on the other side to -2 pi. And then it would repeat itself from 2 pi to 4 pi, and then to 6 pi, and so on. And whenever you're graphing one of these trigonometric functions, your best bet is to take the period and break it up into 4 parts. So we're going to divide this 2 pi into 4 parts. So the middle would just be pi, and then the middle between 0 and pi would be half of pi, or pi over 2. And between 1 pi and 2 pi would be 1½ pi, or 3/2 pi, which we write as 3 pi over 2. And so sine goes between 1 and -1. It starts at 0, 0, and each of these little points that I put in here is where it either reaches a maximum or comes back to the axis. So it starts at 0, 0 and goes up. It goes up to 1, and then it crosses the axis at pi, and then is at its minimum at 3 pi over 2, and then at its maximum, it crosses the axis again at 2 pi. And then if I were to break this next one up into 4 parts, we'll repeat the process. At the first one, it'll go up to its highest point, and then cross the axis, and then its lowest point, and then cross the axis. So it looks like this. Oh, I can't draw. You can see the tremors in my hands when I do that. And it goes on. Whoa, what happened there? Don't do that. Okay, now going the other direction, we're going to have the same thing. And again, divide it up into 4 parts. So I'd have the halfway part would be -pi. Halfway between -pi and 0 is half of pi, or -pi over 2. Halfway between -1 pi and -2 pi is -3 pi over 2. And it's starting here, it's going down in this direction, down, and then crosses the axis, and then it's at its maximum point, and then there. So there, 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 and there. And that is the graph of y equals sine x. And then if you multiply the x by something, or on the outside, you're going to change things, and I'll explain that in another video. And just really quickly, I'll show you what to do with cosine. Cosine is the same idea, except you start at 1. So you start at 1 going down. And so this would be your highest point, and then you cross the axis, and then the lowest point, and then you cross the axis, and then the highest point, cross the axis, lowest point. And you just repeat the pattern. And if you break your period up into 4 parts, that's going to be your clue. Yeah, I can't draw under normal circumstances, and my hand is in a big cast right now, so that's particularly bad. But there it is. So that's sine and cosine, and that's going to be the end of this recording. We have talked about the natural log, which is base e. So we've talked about the natural log, which is the same as log base e. And we have the common log. So if you just see log, that usually means the log base 10. And so you'll see that used in certain applications, like in chemistry. You have the pH is minus the log of the hydrogen ion concentration, and we just see log, that means common log base 10. So you'll see that. You'll also see it in the Henderson-Hasselbalch equation in biochemistry. So you have the common log and you have log base e, but you don't have to have a base of just e or 10. I could have log base 4 of, say, 1/16. And if you remember what that means, is, I'm trying to figure out what value that is. Then the log base 4 of 1/16, if I let that equal x, that's the same equation, or it means the same as 4 to the x equals 1/16. And now to figure out what x is, look at this 16 and say, well, is that a power of 4? And you'd say, yeah, 16 is 4 squared. So I could write that as 4 squared. But that's in the denominator. And if you want to move something from the denominator to the numerator, or from the numerator to the denominator, you change the sign of the exponent. So this would be 4 to the x equals 4 to the negative 2. And so you know that x equals negative 2. All right, so that's good. So you know how to do those. For practice, let's do one more. Let's say that I had the log base 5 of the square root of 125. All right, so set that equal to x. That means 5 to the x is the square root of 125. Now you ask, can I write 125 as 5 to some power? And you'd say yes. If you're not sure, you can try it out on your calculator. 5 to the third is 125. And then you remember that if I have a number a to the p over q, that means the qth root of a to the p. So when I have the square root, that's the same as raised to the 1/2. And so when I have the square root of 5 to the third, that's the same as 5 raised to the 3/2. Because this is 5 to the third to the 1/2. And that's 5 to the 3/2. So this is 5. I don't know why that turned into a squared. That should be an x. 5 to the x equals 5 to the 3/2, and so x equals 3/2. All right. Well, what if it's one that I can't do that with? So if I have log base 2 of 20, and I want to figure that out. What is that? Well, 2 to the x equals 20. There's 2 raised to no power equals 20. I want to get an approximation. I know that 2 to the 4th is 16, and 2 to the 5th is 32. So I expect that it's somewhere between 4 and 5. Now, depending on your calculator, this can be very easy to do, but you also should know the change of base formula. Your calculator will certainly do natural log and most likely common log, even if it doesn't do other bases. So let's do a little proof over here to show why the change of base formula works. So let's say that I have the log base 2 of 20 and I know that that equals some x, and I want to figure out what x that is. Well, I maintain that it would be the log of any base of 20 over that same base of 2, and I would say that that would equal x. So let's see why that's the case. Let's say that I had the log base a of b, and I say that that equals the log base c of b over the log base c of a. Okay, so I don't know what x is, but I'm going to say log base a of b equals x. Now I'm going to take the natural log of both sides. So I'm going to say, actually I'm going to rewrite this. I'm going to rewrite this as a to the x equals b, because I know that is true. That's the same thing that this means. Now I take the natural log of both sides. The natural log of a to the x equals the natural log of b. Then this x can come out in front. So x equals the natural log, or x times the natural log of a equals the natural log of b. And then I can divide both sides by the natural log of a. Cancels over here, and I get x equals the natural log of b over the natural log of a. And I just used natural log, but I could have used any base log. And so it didn't have to be natural log, it could have been any base of log. So equals log base c of b over log base c of a. So if I wanted to have the log base 2 of 20, that is the same as the common log or natural log, doesn't matter which one, natural log of 20 over the natural log of 2. Now, depending on your calculator, you may already have this on your calculator. So if you have a TI-84, or an 83 plus, then if you go to the math menu, you have log base. I'll show you as soon as it comes up. Also have so on this calculator, you would go to the math menu and you go down to A is log base, and then you can fill in the 2, log base 2 of 20, and you get 4.3219, as we suspected, between 4 and 3. Okay, if you have the TI-36, where is that one? So you have the TI-36X Pro, fantastic calculator. You can get to it by pressing the log 3 times, 1, 2, 3, and then you could put in 2 and 20 and press enter. And if you don't have a calculator that has log base, then you use the change of base formula. So to take the log base 2 of 20, it's the log of any base of 20 over the log of any base of 2. Just remember the big number goes on top, the number that's towards the bottom here goes on bottom. So if I take as a fraction the log, any base, I'll use natural log of 20 over natural log of 2. I get the same number.